Sanjay Kumar. He completed his BE Civil Engineering from Madurai Kamaraj University. He also pursued his ME Soil Mechanics and Foundation Engineering from Anna University, Chennai. He worked as a designer engineer for 1 year under a structural consultant in Madurai. He is currently working as a faculty member in the Department of Civil Engineering, Tyagarajar College of Engineering, Madurai. He has organized 2 national conferences at TCE in 2010 and 2014. He's also got 3 publications in international journals. He is an A-lead member for the Geotechnical Consultancy at Tyagarajar College of Engineering.
Welcome to UGC lecture series on architecture. This is lecture number 5 for the subject Mechanics of Structure 1. We are in unit 2, which is analysis of plain trusses. Contents of the lecture are as follows: analysis of simply supported truss by method of joints and analysis of cantilever truss also by method of joints. We shall see the first problem. Find the forces in the members AC, AD, BD, BE, ED and CE of the simply supported truss shown below by method of joints. Now, here we have the truss. Total span of the truss is 10 meters. It comprises of 5 joints. So, number of joints J is 5 and it comprises of 7 members. So, M is 7. Now, for a perfect frame or a statically determinate frame or truss, the following equation should be satisfied. That is, number of members M should be equal to 2 times number of joints minus 3. So, here M is 7, which should be equal to 2 into number of joints 5 minus 3. So, it is satisfying this condition and hence this truss is a statically determinate truss, and hence the unknown member forces can be determined by applying the conditions of static equilibrium. Now, we shall see the solution. Now, this is a simply supported truss with supports at A and B. Now, if you see the loading on this truss, external loading acting on this truss are pure vertical forces, and hence on the 2 simply supported ends will be having only vertical reaction components. So, let VA be the vertical reaction component at the support A and VB be the vertical reaction component at support B. Now, we have to determine the support reaction components by applying the conditions of equilibrium. Sigma V equal to 0, this is the first condition, that is algebraic sum of all vertical forces equal to 0. Once again we are going to assume all the forces going in the upward direction as positive. So, you have plus VA plus VB, the external forces 5 kilonewton is a downward force. So, it is minus 5 kilonewton minus 6. So, these are the 4 forces, algebraic sum of all these 4 forces are equated to 0. From this we get VA plus VB as 11 kilonewton. We shall take this as equation number 1. Now, we shall use the next condition of equilibrium, that is algebraic sum of moments of all forces about any support. We are going to consider the support A. So, sigma MA, algebraic sum of moments of all forces about support A, is equated to 0. Now, once again we have 4 forces VA, VB, 5 kilonewton and 6 kilonewton. VA passes through A and hence it does not have any moment. VB creates an anticlockwise moment about A. Anticlockwise moments are taken as negative. So, minus VB into perpendicular distance between VB and A is 10 meter, minus VB into 10. Then I am extending the line of action of 5 kilonewton force. If you see the triangle ACD, it is an equilateral triangle, and hence the perpendicular distance between the support A and the 5 kilonewton force would be half the base width of the equilateral triangle. Now, the distance AD is mentioned as 5 meter. So, the perpendicular distance between 5 kilonewton force and A would be 2.5 meter. Now, 5 kilonewton force creates a clockwise moment about A. So, we have to put a positive sign for it. So, plus 5 into 2.5. Now, let us consider this 6 kilonewton force. we shall extend its line of action. Now, the distance, perpendicular distance between the line of action of 6 kilonewton force from point D has to be determined. We shall denote that distance as small x. Now, let us consider this small triangle, that is triangle DE, then up to this particular point. We shall take this point as say O. So, right now I am considering the triangle DEO. It is a right angle triangle. So, with respect to 60 degree, x is adjacent side. So, for the triangle, so in triangle DOE, cos of 60 degree angle will be adjacent side x divided by the hypotenuse will be DE. Now, the length of the member AC will be 5 meter, because triangle ACD is an equilateral triangle, AD is 5 meters. So, AC will also be 5 meter. Now, the distance DE will be 2.5 meters. Now, this distance can be applied by applying similar triangle principle, because BD and AD are equal. So, BD divided by BA should be equal to DE divided by AC, that is BD divided by BA must be equal to DE divided by AC. So, from similar triangle principle, BD divided by BA is equal to DE divided by AC. The distance BD is 5 meters. So, 5 divided by BA, BA is the total span of the truss, which is 10 meter. This is equated to DE divided by AC. AC is the member whose length is 5 meter. Therefore, we get DE as 25 by 10, which comes to 2.5 meter. So, that distance is written here. Now, let us come to the triangle DOC. In triangle DOC, we have applied cos of 60 degree, which is equal to x by DE. Now, this DE distance has been determined as 2.5. Therefore, x will be equal to 2.5 into cos 60 degree. So, which will come to 1.25 meter. So, this distance x comes as 1.25 meter. Now, we are taking moments of all forces about A. So, the perpendicular distance between this 6 kilonewton force and A will be the distance AD plus DO. So, which will be 5 plus 1.25, which is 6.25. Now, 6 kilonewton force creates a clockwise moment. So, plus 6 into perpendicular distance is 6.25. Now, these are the algebraic sum of all forces about A. I am equating it to 0. From this, we can calculate the value of VB. VB will come as 5 kilonewton. Now, putting the value of VB in equation number 1, we can get the value of VA. VA will come as 6 kilonewton. Now, this is the first step in the analysis of truss, that is, we have to find out the support reaction components. Now, let us consider the equilibrium of joints separately. Now, we know that the joint that is to be considered should not have more than 2 unknown member forces. Now, initially we shall consider joint A. I am drawing the free body diagram of joint A. So, we have the reaction VA at this particular joint A. Then we have the horizontal member, which is FAB, the force in the member AB. Similarly, we also have the member AC. Let FAC be the force in the member AC. Inclination between these two members AC and AB is given as 60 degree. Now, as a general rule, always the bottom chord member will be subjected to tensile force. So, in order to indicate tensile force, the arrow head should point away from joint A. So, we have assumed force in member AB to be tensile in nature. Now, we shall assume force in member AC to be compressive in nature. Compressive force should have arrow head pointing towards the joint. After assuming the nature of forces for the two members AC and AB, we shall apply the conditions of equilibrium. The first condition of equilibrium will be sigma v equal to 0. FAC goes like this. This is force in member AC, this is joint A. Now, FAC moves from this particular point and it reaches here. To travel from this particular point to reach here, vertically we have to go in the downward direction till this particular point, and then horizontally we have to go towards left. So, this is the vertical component of FAC. We know this particular angle which is 60 degree. So, the vertical component of FAC, that is V, will be equal to FAC into sine of 60 degree. If you see the direction of this vertical component, it is in the downward direction, hence we have to put a negative sign. So, minus FAC sine 60 degrees. Also at joint A, we have the vertical reaction component VA. Since it is a vertical force, we will be putting positive sign for it, plus VA. Now, the vertical component of FAB will be 0, vertical component of FAB will be 0. So, these are the algebraic sum of all vertical components of forces, I am equating it to 0. So, FAC sin 60 is equal to VA. VA is already determined as 6. From this we can get the value of FAC. FAC will be equal to 6 divided by sin 60. So, FAC comes as 6.93 kilonewton. If you see the sign for FAC, it comes as positive, which means that our assumed nature of force for the member AC, that is compressive, is correct. So, FAC compression is correct. So, we have determined the force in the member AC. For determining the force in the member AB, we shall apply the second condition of equilibrium, which is algebraic sum of all horizontal forces sigma h, that is equated to 0. Now, VA is a vertical force, reaction component VA is a vertical force, it does not have any horizontal component. FAB is assumed to be acting towards right. So, the sign convention will be plus FAB. Now, we need to find out the horizontal component of FAC. So, in this above triangle, horizontal component of FAC is H, which will be given by FAC into cos 60 degree. If you see the direction of horizontal component of H, it moves towards left, it moves towards left. So, minus FAC into cos of 60 degree. Now, these are the algebraic sum of all horizontal components of forces, I am equating it to 0. Already we have determined the value of FAC as 6.93 kilonewton. Substituting the value of FAC in the above equation, we can get the value of FAB as 3.46 kilonewton. Once again, if you see the sign for FAB, it comes as positive, which means that our assumed nature of force for the member AB, which is tensile, is also correct. So, FAB is 3.46 kilonewton in magnitude and the nature of this force is tensile in nature. Now, we shall consider the equilibrium of joint B. The bottom horizontal member of joint B is BD. Let the force in that member be FBD. We shall assume tensile force for this particular member, hence the arrowhead should point away from this joint B. The other inclined member is BE. Let FB be the force in that particular member. We shall assume compressive force for that member. The inclination between member BE and BD is given as 30 degree. So, this angle is 30 degree. The vertical reaction component at B, that is VB, has been already determined, which is 5 kilonewton. Now, let us apply the condition of two conditions of equilibrium. The first one will be sigma V equal to 0. Algebraic sum of all vertical components of forces. First of all, we shall consider VB. VB acts in the upward direction, so it is plus phi. FBD is a horizontal force, it does not have any vertical component. So, vertical component of FBD will be 0. Now, let us consider FBE. FBE acts like this. So, this is FBE. It starts here and it ends up at joint B. So, it starts here and it ends up here. In order to travel along this direction, we should go vertically up to this particular point in the downward direction, and from this particular point we will be reaching point B in the horizontal direction. So, this inclination is 30 degree. So, vertical component of FBE is denoted as V and horizontal component of FBE is denoted as H. Vertical component of FBE will be V, which will be equal to FBE into sine of 30 degree. Similarly, the horizontal component of FBE H will be equal to FBE into cos of 30 degree. Now, we are using the condition sigma V equal to 0. So, plus VB, then vertical component of FBE, if you see the direction of vertical component of FBE, it is in the downward direction. So, we have to put a minus sign. So, which is minus FBE sin 30, which should be equal to 0. From this we can get the value of FBE. FBE will come as 10 kilonewton. If you see the sign for this force, once again it is positive, which means that our assumed nature of force for the member BE compression is right. So, FBE will be 10 kilonewton compressive. Now, we shall apply the second condition of equilibrium, which is sum of all horizontal forces equal to 0. VB is a vertical force, its horizontal component will be 0. FBD is a horizontal force, it goes towards left, and hence we have to put a negative sign for it. So, minus FBD, then horizontal component of FBE, horizontal component of FBE is here, which is FBE into cos of 30 degree. If you see the direction of this particular horizontal component, it moves towards right, and hence we have to put a positive sign. So, plus FBE into cos of 30 degree. So, this is the algebraic sum of all horizontal forces at joint B. I am equating it to 0. Already we have found out the value of FBE. FBE is 10 kilonewton compressive, from which we can get the value of FBD. So, FBD will come as 8.66 kilonewton, which means that our assumed nature of force for the member BD is right. We have assumed tensile force for the member BD, and hence FBD will be 8.66 kilonewton tensile. Now, this is the joint E. In joint E, there are totally 4 forces, 6 kilonewton force acting in the downward direction, then we have FBE, FDE, and finally FCE. FBE has been already found out. The nature of the force in the member BE is compressive. So, we have the arrowhead pointing towards the joint. FDE is assumed to be tensile in nature. So, arrowhead points away from the joint, and FCE is assumed to be compressive, arrowhead points towards the joint. We are applying the first condition of equilibrium, which is sigma V equal to 0. 6 kilonewton force acts in the downward direction. So, minus 6. Vertical component of FBE will go in the upward direction. It will be plus FBE into sine 30 degree. FDE acts from this point and reaches here. So, the vertical component of FDE will be FDE into sine 60 degree. Since it goes in the downward direction, we will be putting a negative sign. So, minus FDE into sine of 60 degree. The final force will be FCE. The vertical component of FCE will be FCE into sine 30. Its direction will be in the downward direction. So, we have to put a negative sign for it. So, it will be FCE into sine of 30 degree. So, I am equating it to 0. Simplifying this equation, we get 0.5 FCE plus 0.866 FDE. This will be equal to minus 1. Now, we shall apply the second condition of equilibrium, which is sigma h equal to 0. Applying this condition, we get 6 kilonewton force is a vertical force. So, its horizontal component will be 0. Horizontal component of FBE will be minus FBE into cos of 30 degree. If you see the horizontal component of FCE, it goes towards right. Its magnitude will be FCE into cos of 30 degree. So, it will be plus FCE into cos of 30 degree, and the final force is FDE. Its horizontal component is here, it is moving towards left. Magnitude of this horizontal component will be FDE into cos 60 degree. The horizontal component of FDE moves towards left. So, we have to put a negative sign for it. So, it is minus FDE into cos of 60 degree. So, these are the algebraic sum of all horizontal forces. We shall equate it to 0. Simplifying this equation, we will be getting 0.866 FCE minus 0.5 FDE, which will be equal to 8.66. We shall keep this equation as number 2. Already we have got another equation by applying the condition sigma v equal to 0. This equation is taken as number 1. Now, we have two equations in which the unknown quantities are FCE and FDE. So, solving these two simultaneous equations, we can get the value of FCE. FCE will come as 7 kilonewton. So, FCE comes as positive, which means that our assumed nature of force for the member CE compressive is right. So, FCE will be 7 kilonewton compressive. Now, if we calculate the value of FDE, FDE comes as minus 5.2 kilonewton. Since minus sign is coming for FDE, our assumed nature of force for FDE, that is tensile, is wrong. So, it has to be compressive. So, therefore, FDE will be equal to 5.2 kilonewton compressive. Now, by this way we have determined the required unknown member forces by method of joints. To summarize, we have seen an example problem in the analysis of a simply supported truss by method of joints. Now, students can try out these questions. Determine the forces in all the members of the simply supported truss shown below by method of joints. Totally there are 7 members in this truss. You are asked to determine forces in all the 7 unknown members. With this, we have come to the conclusion of this lecture. Thank you.